all this topics. We are going to discuss about all the topics here. So the first thing is we'll discuss about how TTL is used to find the, if we have some routing issues, and how with the use of TTL, how we going to find it. So to do that, let me open up the whiteboard here. So we'll see the TTL values, the practical lab. So here I am just giving a refresh about TTL. So we know that TTL 255 is for Cisco devices and TTL 128 is for Windows, and some Linux devices it uses TTL 64. So the objective is what exactly the TTL is used for. So especially when we have some problem with routing, if my TTL is not decrementing, we discussed about that. So it is from my source. So if it is a Windows PC, the first ICMP packet will be sent with TTL 128. And if this TTL is keep decrementing in every hop, so it means that it is going through the multiple devices in the middle. If my TTL is not decrementing, then there is a problem with the routing. So the TTL is set, the TTL value is purely decided by the operating system, by the source. We all know about that. So we'll do a simple lab where we can see how this TTL is really decrementing, or how it behaves. And Wireshark will do a capture, so that everybody will be aware of, okay, how this exactly the TTL works practically. So to do that, let me open up the GNS. Let me start this devices. So here it's my fast Ethernet 1/0. And if you want to connect any other devices, as I told you, the fast Ethernet 0/0 and 0/1 are the routed ports. So if you do any, if you choose any other interfaces here, it's going to work as a switch port here. So let me change this. So I want this to be a routed port now. So I'm going to choose the first port. So interface fast Ethernet 0/0. I'm just giving an IP address 10.0.0.1, and it is just a class A address. Let me open up a router. If I give shows CDP neighbor, no ports is configured for now. So let me configure the port. Interface fast Ethernet 0/0. No shutdown. Then let me configure the other port. Interface fast Ethernet 0/1. No shutdown. Let me try to find the port details here. So my router is connected on fast Ethernet 0/0. Let me give an IP address here. The face fast Ethernet 0/0. IP address 10.0.0.2. Shutdown. Do a self ping. Okay. So I got a reachability here. So here, fast Ethernet 0/1. Let me assign an IP address here. Face fast Ethernet 0/1. IP dot address 11.0.0.1. And the default gateway here. So I'm going to this switch and I'm going to enable the routing. So this is a layer 3 switch. I have to give an IP routing command. If I give show IP route 11.0.0.1, says it's not in the subnet table. Sorry, it's not in my routing table. Show IP route. It's only I know about the directly connected devices. If I try to ping this, I cannot. So what I'm going to do, let me make a static route pointing to this. Configure IP route 55 to 55 or 255 or 255. If this is only for this specific IP address, and if I want to go here, I want to go out of, sorry, I'm going to do routing for 11.0.0. What is my network show run interface? Fast Ethernet 0/1. So for this 11 network, I'm going to make this all has to go out of 10.0.0.2, my next hop. Show IP route 11.0.0.1. So it says that my next hop is 10.0.0.2. If I try to ping, I can ping now. So now let's see. So I'm 1 to 2 IP address and I'm 2 hop away here. Let me start this capture. So here I am going to give IP dot address equal 11.0.0.1. So now I'm going to generate a traffic for 11.0.0.1. And for my ICMP ping request, I get a ping reply. So if I go back here, I can see the ICMP data. And along with that, here I have assigned the TTL here, right? So this is from my source 10.0.0.1 to 11.0.0.1. So I can see the TTLs here. Same if from the return route from 10.0.0.1 to 11.0.0.1, So TTL is 255. Let me go back here. So if I go to, let me configure one more IP in the router. I have 10.0.0.2 and 11.0.0.1. Let me assign an IP address to this PC. You give a question mark for this VPC, you know how this commands can be used to assign an IP address and all these details you will see here. So if I give IP question mark, it will show me the format to assign the IP address. So I'm going to assign 11.0.0.3.255.0.0.0. I have to specify the subnet mask like this. 11.0.0.5/8. And my default gateway is 11.0.0.1. So if I do a self ping, I can ping. If I do it for 11.0.0.1, it says not reachable. If I give show IP ARP, I can see the ARP resolution for 10.0.0.2, 11.0.0.1. Let me try from here. 11.0.0.5. So let me run a capture here. Let me make it as an ARP. So this is a command. So it monitors all the traffic. So if I do 11.0.0.5, so I can see the same ARP broadcast here. So it's saying who knows about 11.0.0.5. Here you can see this source has been sent with my MAC address, whereas ARP is a broadcast. So I don't know the destination MAC address. So it's all zeros. It's going to send all zeros, and it sends this on fast Ethernet 0/1. If I give show IP interface brief, so it's in this ARP request back here. This is just a directly connected devices. And if I check the IP config, show IP, so I'm going to verify all the config looks perfect. So my gateway is 11.0.0.1. It's fine. And my subnet mask is 11.0.0.1. And the subnet mask is /8. All looks good. I don't think we can connect this virtual PC with this router. I give trace 11.0.0.1. So it says host unreachable. Okay, fine. So let's initiate a ping again from here to 11.0.0.5. Anyway, we do not have a routing here. So if I do ping for 11.0.0.5, if I do a capture simultaneously, I got a capture for fast Ethernet 0/0 to this router, fast Ethernet 0/0. IP address is 11.0.0.5. So I've sent the ping request, but I'm not getting a ping reply back. So it says no response found. And my TTL is not decrementing. So let me remove this device and let me add one more router. So let me change the name as test. Interface fast Ethernet 0/0. IP address 11.0.0.5. Subnet mask would be 255 or 0.0.0. No shutdown. So let me try to ping 11.0.0.5. Yes, I can ping. From the switch, I cannot. So if I go to this router and if I give show IP route, show IP interface brief. If I try to find the 10 network here, so it doesn't have a route. So to reach 10 network, so I have to make a static route. A500, and my next hop would be router 2. So I'm on 11 network. So my next hop would be it's 11.0.0.1. To reach 10 network, I have to go through the gateway, the next hop. So if I give show IP route 11.0.0.5, I can. And if I ping 11.0.0.5, now I can ping. So let me do a trace route again from the switch. So I got a capture here that's going between fast Ethernet 0/0 to fast Ethernet 0/0. If you see here, the TTL is decrementing, right? So let me open up the, where is my big pen? You can see the TTL is decrementing here. Go back here for 11,005 to 10,001, the TTL is decrementing. So why I have shown this for the directly connected devices, you won't see this TTL decrementing, but this device is 2 hop away. So it has to do a, no, this is a directly connected. So for this, your TTL will never be decremented, right? So your TTL decrements when it hover over the routers. So if you see this, if this particular network, 10 network, it has to reach this 11,005, so the TTL value will be decremented. So that's how now I can conclude, okay, my routing is happening now. If your TTL is not decrementing, then there is a problem with routing. Fine. So next, go to the second topic. You guys cannot hear me? Hello? Okay, you can ping me in the chat. I mean, can able to hear you. It's audible. Okay. Sure, sure. We'll discuss this. Okay. All right. So, Sai, I think you have to check the microphone. Can you please try unplug and connect it back? So, anybody is facing problem in hearing me, you can ping me in the chat. Okay, so the second topic is, let's see the coloring rule in Wireshark. So let me open the Wireshark here. If you go to view coloring rules, you can create your own coloring rules. Example, if there is an ICMP already, so if I wanted to, example, if I want to do a coloring rule, something like this. Let me copy this. Let me go to view coloring rules. And here you can click the plus button here, and you can give your own name, something like source. And here's the value you have to give. So once you do that, you can choose your background color. So here, for an example, let me choose this green. Okay. So for this source, it's going to be a dark green color. So you can create your own coloring rules. So to do the coloring rules, all you have to do is you have to go view coloring rules. And if you press on the plus button, you can give your user defined name and you can apply the filter here. So I would suggest all these rules will be very important when you do the TCP handshake. If you want all your SYN packet has to be in a different color, you can make your coloring rule with TCP SYN. And for any rules, this is your freedom, so you can create your own rules. This is all predefined rules. And if you want to do a custom rule, you have to press the plus button and you can apply the filter here and you can choose your color. So I would suggest you can use this background color. So it would be helpful for you to track down your filters, the Wireshark. So let me go into remove this. So the next thing is, what is delta time? Let me tell you. So delta time is very important when you troubleshoot issues. Something here, if you see, this is something, this is the time since the first packet has been sent from source to destination. So it is waiting for 62 milliseconds. So when you see the values increasing here in the left-hand side, that is your seconds. So mostly if it is increasing something like 1 second, 2 seconds, 4 seconds, I would say definitely it is a slowness. So as far as your time values is in the milliseconds, your connection is good. So delta time is basically, it is used for, to check the round trip time. So it's for round trip time. What is round trip time? So example, this is 2 devices. So if I do a ping, example here from a source, and this is a destination. So it's the amount of time taken from the source to destination and back. It's a bi-directional, from source to destination and from the destination to source. So this is called as round trip time. So it has taken 62 milliseconds for my first packet to go there and to come back. This is where I have initiated my first ping and I have to wait for 62 milliseconds. And the second ICMP request, it takes 46 milliseconds. This is when comparatively the first ICMP packet, it takes time because your OR process happens there. If you do a ping, it is not that you reach your destination on the fly. So it has to go through the OR process, because I don't know the destination MAC address, but I don't know that I don't know the destination MAC address, but I know the destination IP detail. So we'll discuss about that OR process in detail in the future classes. But ARP is something when I want the destination IP address, only then I can forward it. So for this 11.10.0.0.1, it is in a different network here. So I'm sourcing my packet from 11.0.0.5. So for my ARP request, I have to get a reply back from someone with the destination MAC address. Only then the packet will be forwarded to the destination. So initially, the amount of time taken will be little higher for the OR process to go through. So once it is done, so this is just, again, all your other ICMP packets will go on the fly. So that's why it takes time. So if your round trip time is really increasing, there is a problem with your network. So as I told, it is always good to have this in the millisecond. It should not go in the seconds. If it goes 1 second, 2 seconds, or it's going more than a second or 2 seconds, this again, there is a congestion, there is a problem in your network. Right, but anyways, if it goes to multiple hops, that's fine. But in some cases, it will go something like 9 seconds, 10 seconds, and I didn't get a response, and definitely there is a slowness. Then, so the main ideology of delta time is something, it has to be in milliseconds, and if it is in seconds, if it is going beyond 5-6 seconds for an application communication, or if it is a round trip time, then there is a serious problem in your network. So it is very helpful. And to do how I can change that, the delta time value, you have to, in the Mac devices, I think you have an option, something like Wireshark. Under Wireshark, you got an option called preferences. Whereas here in Windows, you have to go to edit preferences column, and you have to, so I did the delta time already. So if you go here, if you make it as a delta time, and if you go for the filter with the delta time displayed has to be selected here. So once you're done, you can click OK. This is the first thing. And the second thing is you have to go edit. Have to go to edit, preference, columns, and you have to check all this predefined value has been set. And here, if you want to customize your columns, if you see, these are all the columns which I have predefined. This TTL, TCP segment length, calculated window size, time to leave, sequence number, acknowledgement number, identification number. All this are important, and we mostly use all this. You can add your own columns here. There is two ways to add. One is right click and do it. One is to right click and you can add it as a column here. Apply as a column will apply, and other ways you can go to edit, preferences, in the columns, you can add your values here. So this is about delta time. So in the future classes, we'll see for TCP how this delta time is used, and for ICMP and for every protocol, this delta time is very important here. So only then you come to know about the TTL value. So now let's see if this particular communication, let's take this example. So if you want to see the statistics of IP details, something like from my source, how many communication happened, how many IP communication happened. From my source, how many TCP connection established. From my source, how many UDP communication happened. So you can see all this detail. Something like your monitoring tool. If I go to statistics, endpoints, if I go to IPv4, so now my communication happened between 10.0.0.1 and 11.0.0.5, and you can see the total number of packets, receiving traffic and sending traffic. All these details you can see. So there is no TCP connection established so far, and you can see all your Ethernet details here. No TCP and no UDP communication, only layer 3 and layer 2 communication happened here, and you can specify your own protocols here. So this is how you can find the endpoint traffic. If you open up this production network, or if it is an active connection that is connected to internet, if I take the Wireshark from my PC. So if I go to my Wi-Fi adapter here, and if I go to statistics and endpoints, I can see all my TCP connection. So this is all my source. This is all my source IP, and this is my destination IP. And you can sort out this value. So you can, based on this, you can prefer the higher value has to be sorted out. You can do it. So if you want to go with minimum value, you can do this. You get to know about all this information, RX, TX traffic and everything. This is something to find. Is it mine? my PC is really connected to the network, and the communication is happening across. So this will give holistic view of, okay, I got access to internet and I'm communicating to many public IP address, and my traffic is really increasing. And you can also see the port details. So this is a server port 443, and this is all my PC random ports used. So for every communication, the port number is different, right? My source port number is dynamic, and it's going to change for every TCP communication. So you can see all these details here. And if you see your IP communication, you can see all your IP communication here. So number of packets and the amount of data, and your UDP, I got 298 UDP streams going on here, and your IPv6 communication. This is really helpful for you to check from the user PC standpoint. If somebody says if they are not connected to internet, this will definitely give you a quick view of what's exactly happening from his PC. So let me stop this. So this is how you can see your active traffic that's going on from your PC to your destinations. And if you go back to the expert info, so this is very useful tool. If you go to the left corner of your Wireshark in the very bottom, if you click on it, it's going to show you all your errors, warnings. Example, if I want to see how many DNS response retransmission happened, it's going to say this. And you can apply access filter. So if you see, these are all my DNS related response, standard query response. And if I go back again, I have to remove this filter back. And example, if I go somewhere, let me check my retransmissions. So this is all the retransmission happened. If I go here on the retransmission, if I click on it, right click, apply as a filter, and you can see all your retransmission in one single click. You'll see all the retransmissions here. If you go here, you can see all the retransmissions. And if you want to be very specific with the IP address, you can do IP dot address equal 192.168.0.104. So this particular conversation is a only TCP retransmission. So my PCs keep retransmitting the data here to all this destination. So this is one particular destination, it keep retransmitting. So it can be not a proper TCP connection, or something happened in the middle. And if I see here for all this retransmission, my TTL, it's stable here. If you see here, my TTL is decrementing. So definitely there is a routing and there is something problem in the middle. So it can be an application or it could be something else. But the objective here is how I can make use of expert info to check all this. And if I close this filter and if I go to expert info again, and if I want to see only the duplicate acknowledgement, I can go right click, apply as a filter, and if I do a select, and it's going to show me only the duplicate acknowledgement here. This is a quick handy filter you can use to filter your TCP errors respective of any protocols. So all in one fly. From here, you can find out, is it something problem with your network there? You can explore multiple options here. Here it is talking about the TCP window size problem. So you can explore multiple options with TCP, UDP. You have multiple options to select. So this is one handy tool where you can check. So this is all mol form packets here. So you can see a lot of information here. So this is all about FIN, your TCP FIN. So it's going to show all my FIN packets. To verify the same, let me go here. And if you see, all your FIN byte has been set. So this is about expert info. Now let's see how to do a span port in a device. So let me open up the GNS again. So let me stop this capture. Let me go to this switch. So for vendor to vendor, the command may change, but here the objective is how we can do a span port. So you should see a similar command like monitor there in other devices. So monitor session, and I can do only 2 sessions. This is a pretty old switch, but it depends on the platform. So here I'm going to give monitor session 1 and source. And the interface, my source interface is fast Ethernet 0/0. That I cannot do this in router port. Let me check this. Monitor session 1 source interface fast Ethernet 1/1. I think we cannot do it in router port in GNS. So monitors session 1 and the session should be same. And the destination interface, it should be my local switch. So let me give fast Ethernet 1/1/2. So let me connect the device here. We start this phase fast Ethernet 1/2 motion on. To run interface fast Ethernet 1/2. Let me check. So nothing, no config. Let me just make it as VLAN switch port access VLAN 10. It's VLAN database VLAN 10. Configure interface VLAN 10. IP address something 50.0.0.1 to 55.0.0.0. So let me go to this port. Switch port, access VLAN 50. Oh, sorry, VLAN 10. Push it down. Show interface followed by the switch port command. So trunk is disabled, operation mode is down. And I've allowed VLAN 10 here. If I go check. Can you see this is in monitoring mode? So the line protocol is down and it is in monitoring mode. So it can only monitor the traffic and now it cannot send any IP traffic here. It is in monitoring mode. So if I do a capture here, start capture. If I go to switch, this particular switch, interface, fast Ethernet 1/2. So I've allowed trunk to run interface fast Ethernet 1/2. It's an access port 10. So this is in monitoring mode. So I cannot do anything else. So let me offload the traffic from fast Ethernet 1/1 and 1/2. I don't see any traffic, right? So monitor session 1. Okay, so I have to select both my ingress and egress traffic. Monitor session 1. So here the interface I'm going to select is fast Ethernet 1/1 and both. And destination, interface fast Ethernet 1/2 and both ingress and egress. Let me go here. Let me try to generate some traffic. So let me ping this device. Let me ping this router, fast Ethernet 0/0. From this switch. this. I don't know why I cannot send the traffic. /. So my link protocol is down, so I cannot send any traffic here. So it is supposed to be fast Ethernet 0/0. Need to remove the labels. Let me give show CDP neighbor. I don't see anything. So this is something physical connection is broken. So it has to be on fast Ethernet 0/0. Let me delete this. So I gave fast Ethernet 0/0. So let me give show monitor session 1. Both fast Ethernet 1/1 and 1/2. So let me delete this. No monitor session 1. Show monitor session 1. It's removed, so I'm going to create a new one here. I give show IP interface brief. So this is fast Ethernet 0/0. So if I ping 11.0.0.5, we cannot ping it. And if I do interface VLAN 10, no shutdown. Show IP interface brief. If I give shows VLAN switch, so for my VLAN 10, I have assigned port 1/2. So let me see the config. To run interface fast Ethernet 1/2. All done. It's on VLAN 10, and I have assigned VLAN 10. Shutdown and no shutdown. Port came up. So IP interface brief. Primary protocol. Okay, it's in monitoring mode. Set show interface. /2. Okay, now my line and link protocol and my physical protocol both are up. It should be up. VLAN 1 is fine. Okay, now my line and link protocol both are up. Okay. So let's do this again. So what I have to do, I have to mirror all the traffic from fast Ethernet 0/1/1. So we have to sort out why this fast Ethernet 1/1. So I haven't connected anything in fast Ethernet 1/1. So I have to make a connection to, this is giving a wrong port details. So let me check, show CDP neighbor, show CDP neighbor. And my router is connected on fast Ethernet 1/1. And I have to connect this back to fast Ethernet 0/0. Let me go delete this. Okay. So on my router to show CDP neighbor, the test is connected on fast Ethernet 0/1 and the switch is on fast Ethernet 0/0. To run interface fast Ethernet 0/0. Okay, 10.0.0.2. Just for a quick check, let me ping 10.0.0.2 and I can ping now. Okay, so now monitor session 1, source interface fast Ethernet 0/0. Why this is creating a problem here? I think we cannot do this in router port. So I have to do some config changes here. Let me go delete this port again and connect it to any switch port. Fast Ethernet 1/3. It's connected to fast Ethernet 0/0. Okay. Show IP interface brief. Let me go into delete this. Interface fast Ethernet 0/0, no IP address. And now if I check the connected port, its router 2 is connected on fast Ethernet 0/0 and 0/1. I'm going to flash all this. So from the router, if I give show CDP neighbor, so the test device is connected on this and this is on fast Ethernet 0/0. Okay. Show IP interface brief. Interface fast Ethernet 0/0. And let me going to remove the IP address and I'm going to do create a sub interface just to tag the packet for VLAN. Encapsulation.1q. So the VLAN, what we created here is show VLAN, show IP interface brief. It's VLAN 10. So now I'm going to assign an IP address, same IP address. VLAN 10 IP address 10.0.0.9 255.0.0.0. And I have to make this port as a trunk. Only test. Switch port access, sorry, switch port mode trunk. What is it? Why I cannot? Wait, interface brief. One slash two and 1/3 are connected, and 1/3 we have connected here. We made it as a trunk and it came on, both are up. Okay, so it is on faucet and it's 1/3, it is on trunk. And show interface trunk. VLAN 1 and 10 are allowed. So I give show IP interface brief. IP address I have assigned. Okay, I can ping. So now monitor session 1 source interface fast Ethernet 1/3, both ingress and egress. Monitor session 1 destination interface fast Ethernet 1/2. Let me check, is it in monitoring mode? So interface fast Ethernet 1/2. It's in monitoring mode. So I'm going to generate some traffic from here. Close all this. So I'm going to open only this. Slot capture. Okay, so here this is a source and it's all offloaded to this. So I have to really open this. Okay, so if I ping show history, ping 10.0.0.2, okay, IP dot address equal 10.0.0.2. So I can see ICMP packets here. So and if I ping 11.0.0.5, like this particular traffic it's showing. Yep. But not this 11. Okay. You actually see this, all this outbound traffic, whatever I send here, This mean I did the port mirroring. I'm offloading all this traffic here. So if it is a real PC, so you can open up your Wireshark here and you can see all the packets that's going on from this egress traffic, both ingress and egress traffic, whatever it goes in this particular switch. And if you want to troubleshoot something with your trunk link that's connected to your router, in the real time, you can see all your TCP traffics. Here we are just generating the ICMP. So you're just seeing the ICMP packets here. So this is how you can do a port mirroring. So let me go through. So you have to give show monitor session 1. And here you can see I have specified both inbound and outbound for fast Ethernet 1/3, and your destination port is 1/2. And this particular model, it's not supported for VLAN filters. So you can use sample monitors session 1. Source. You can specify your VLANs. Example VLAN 10, both. So this particular platform doesn't support the VLAN, but in the real devices, it supports your VLAN traffic. You can specify your VLAN traffic. Example, if any user on VLAN 10, if he cannot access anything outside, you can offload this traffic. You can, you can make this session trace only for that specific VLAN, and you can do a capture. That is also possible. VLAN and along with the interface. So interface is something you are capturing all the packets. So VLAN is only specific to the VLAN. So when you're giving the VLAN, you have to be very careful about that, because it may spike your CPU. So if you want to really interested in all the protocols and not respect to the VLAN traffics, yeah, VLAN for that specific VLAN, you will get it. But this is a routed port. So if you want to capture all the traffic, that's whatever it is egressing out on this particular interfaces, you can see everything in the Wireshark in the same way here. So this is for the demonstration. That's why we see only this ICMP in the production network. You see all kind of traffic here. So example, if I go to this particular router, and if, okay, let me turn off the debug. If I go to fast Ethernet 0/0, and if I give shutdown, and what happens now? Show IP interface brief. So if I go to this switch, if I ping, for your ICMP request, I'm not getting a reply back. So only I got request and I didn't get any reply. So this is one typical example. So you can make use of for your TCP and all other stuff. This is how you can do port mirroring. And in some devices, in other Cisco devices, is not supported, but actually that's pretty simple. That is something like monitor command, and you can give a command something like capture. And is it the same thing like what we did for VLAN or for all the interfaces? So what is the difference between this is a global capture. This is not for any specific interfaces. This is about the traffic that is going through your router. So you can capture everything, and you can save the capture inside the flash, your storage in the box, and from here you can offload to any TFTP server. And this particular TFTP server that's running an application, there you can open up your Wireshark and you can open this file, and you have to save this as a PCAP file. So that is important. You have to save this as a PCAP file, and you can export this. And from this, you have to export this to your TFTP server, and from there you can open up your Wireshark from your PC. Then you can go through all these packets and you can do your troubleshooting. So that is also one way of doing it. But this is something from the port. This is called port mirroring. From one port, I'm offloading all this traffic to this particular port, and I'm doing a capture, and whatever the traffic that goes out and in, both ingress and egress traffic, I can capture here. So what else? So we got span ports. We can MTU lab for fragmentation. It's fine. So let me now open a Q&A session.